Here's the second example. Magnesium metal reacts with hydrochloric acid to produce magnesium chloride in solution and hydrogen gas. How many hydrogen molecules are produced when 60.0 grams of magnesium is reacted with excess hydrochloric acid? We need to start with a balanced chemical equation. Magnesium, solid at room temperature, hydrochloric acid, HCl. All acids are aqueous. They are dissolved in solution. This is going to be a single displacement reaction. The magnesium is going to displace the hydrogen. That's going to give us hydrogen gas. And the magnesium and the chlorine will combine, but magnesium has a 2+ charge. Chlorine has a 1-, so we're going to need 2 chlorine. And that will be aqueous because this would have been a solid piece of metal. Here's the magnesium. Here's the acid in water. So this is a solution of HCl in water. You put the magnesium in, it starts to displace the hydrogen gas leaves, and the magnesium metal becomes dissolved in the water. Here's the skeleton equation. We need to balance it up. 1 magnesium, 2. We are going to need a 2 here, and that will balance it. So here's our molar ratio, 1 to 2 to 1 to 1. Let's now see what we're interested in. It says how many hydrogen molecules. So this time we're not interested in mass, we're interested in number. So at some point we're going to need Avogadro's number, 6.02 times 10 to the 23, and in this case it will be molecules per every 1 mole. Okay, but we're going to also need to know how many moles of hydrogen gas are produced in order to then convert to number. So what do we start with? 60.0 grams of magnesium. So the mass of magnesium is 60.0 grams. We no longer need to worry about the hydrochloric acid or the magnesium chloride. Just like in the previous example, we needed that to get the right stoichiometry, the right molar ratio, but from here on out, we're only interested in looking at magnesium and hydrogen. This is a 1-to-1 ratio. That's going to make this example a little bit easier. For every 1 mole of magnesium that reacts, we get 1 mole of hydrogen gas. So, molar mass of magnesium is 24.31 grams per every mole. That information comes directly from the periodic table. And we're going to have to use this information to find moles. So step 1, find moles of magnesium. Okay, little n is our symbol for moles. We're going to take our mass and we're going to divide it by the molar mass. Grams cancel out, so I'm convinced that I'm doing this correctly. I am going to take 60.0 and divide it to figure out how many times 24 goes into 60, and 2.47 moles. When I think about that number, I have 60 grams, 1 mole is 24 grams. I have more than a mole. That number seems very reasonable. Step 2. You're going to convert moles of magnesium to moles of hydrogen gas. So find moles of H2. Well, there's no calculation to do. All we need to do is state that the molar ratio is 1-to-1. Therefore, the moles of H2 is 2.47 moles. Step 3, we need to find the number of hydrogen gas molecules. Molar number is going to be equal to our moles, 2.47 moles times 6.02 times 10 to the 23 molecules